Okay, so it started recording now. Okay, so on your lab notebook, the first thing I want you to do is write the purpose of the lab. Purpose. What is the purpose of the lab? What did we want to do in the lab? Anybody remembers? Yes, Ian. To determine the percent of copper in a penny. All right, what materials did we need? What were the materials? Okay, a penny, that is correct. Post 1982 penny. All right, what else did we need? Anybody remembers? Yes. All right, so hydrochloric acid. Let me actually write it here. There's no space. All right, hydrochloric acid. What else do we need? What else do we need? A file. A file. What else do we need? Yes. A beaker. What else do we need? Yes. A scale. Anybody else remembers anything else that we need? All right. Today we are going to, yeah? Yeah, the file that we use to file the penny, right? All right. A scale, and we need a wash bottle. We're going to wash the penny today, and we need a forceps. All right. So let's see. We are going to write the procedure next. So before I write the procedure, let me remind the students or ask them, what are the two things a penny is made of? Copper and zinc. All right. So who remembers what we did first? Evelyn, loud and clear. What did we do? We measured the mass of the penny. Okay, let me ask the class. Now, I don't remember how you did this. Did you file the penny first and then mass it? Or did you mass the penny and then file it? You mass the penny first? All right. So write down step 1 is determine the mass of penny. So Sophia, are you cool so far? You just take the penny, put it on a scale, and you take its mass. Ali also? You understand what's going on? All right. What was the next step? So a penny consists of copper and zinc. Who can tell me what was the next step? We filed it, right? So how do you file a penny for those who are absent? All right. So this is the edge, right? The penny on the outer layer is full of copper. All right. Where is the zinc? The zinc is on the inside. So we are going to find the percent of copper in the penny, which means, do we need the zinc? We need to get rid of the zinc. And how do we get rid of the zinc? By adding hydrochloric acid to it. All right? But the hydrochloric acid should reach the zinc. Is that right? How do we let the hydrochloric acid react with the zinc? Filing is just like scratching. All right? If you scratch like this, what will you see? You will see a silvery surface on the inside. And what is that? That is your zinc. So you file it in 3 different places. Do you understand? So let's write down the next step. File the penny. File the penny on its edge on its edge in 3 different places. Then what? What did we do next? What did we do next? Anybody? We put it in acid, all right? Place or place the penny in a beaker with 20 ml hydrochloric acid, 20 ml HCl. All right? That's hydrochloric acid. That's hydrogen, capital C and lowercase l. All right? Hydrochloric acid. Now we don't know what we are supposed to do. Is that right? We left the penny in the acid overnight, right? Place the penny in a beaker with 20 ml acid and leave it overnight, because we need to give time for the acid to react with the zinc, right? Now, yes, what would you like to say? We were going to mask the penny again. So Ian remembers that. So in the penny, all the zinc should be gone. Is that right? What should be left? Only the copper should be left. All right? So let me show the class what is the next step. All right? I did drain the acid out from some, but I'm going to do it for the others and show it to you. All right? So here are your beakers. We did it in 5 groups. All right? So the acid is pretty concentrated. So what is my first step? And I'm going to do this for you because the acid is pretty concentrated. All right? Pardon my safety this thing because I'm supposed to have goggles and everything. Anyway, so here is a glass rod and I'm going to pour the liquid down. Look at that. It will not only break the penny, not let it fall, but there is no spill. Do you see that? Do you see that? Does it help me transfer nice and clear? All right? Okay. The next thing you need to do is, I have wash bottles in all your stations. All right? What I need you to do is, I need you to wash your penny 2 to 3 times so that you get rid of all the, you can get water from the sink if you need in your wash bottle. All right? And I need you to wash your penny a couple of times with water so that all the acid and if there is any zinc that has come out that has not left the beaker, we need to get rid of it. All right? Does that make sense? You can pour it out. You don't have to use the glass rod. You can just make sure that all the zinc is coming out. You can tap the penny a little if you want. All right? You can just pour it out. Does that make sense? And at the end, I'm going to give you a paper towel and you're going to dry the penny with your paper towel. And then what do you do after you dry it with your paper towel? You need to mass it. All right? So, and then once you wash it 2 to 3 times and you dry it, you can actually feel it with your hands if you want. All right? If you feel it with your hands, you will actually realize or be able to understand how much of the penny is copper. So group this is 5, section 5 here. Keith is not here, Mrs.
I see that, and I'm not happy.
And you just tell me he's not absent on a game day. I just hope he's here later on in the day.
Well, I want
Or,
to hear now.
huh?
I want to hear now.
I know. I'm recording the lecture too. All right, guys. Please get up and go to the group in which you are. All right. Wash it 2 to 3 times. Or actually, for paper towel, you can use Dry your... Come on. Oh, sorry.
Good, Ollie. I want you to be concerned. I am.
This friend came running to make it on time today. I made the class back for her.
Oh, good. I'm old, and my heart can't take on.
Procedure. So we placed the penny in a beaker with 20 ml hydrochloric acid and we left it overnight. What did we do after we came back? What was the first thing you need to do? Drain the acid, right? Drain the acid and wash the penny. Wash the penny 2 to 3 times with water, right? And then what did we do? We dried the penny with paper towel, and weighed it. All right. The next thing in our notebook is our data table. Okay? So we did the lab and we collected data. There is a before column and there is an after column. Now, in the before column, we wrote our observations before. What did the penny like? I would say it was brownish black. All right? It was brownish black. It was circular. All right? And anything else you wanted to write. Now, after, does it look really shiny? Does it look really shiny?
Very shiny.
All right? Shiny and whatever you want to write. All right? Whatever shape you want to write, you can write. Now, can somebody share their mass of penny before?
Anybody? What was your mass?
Mass of the penny before. Who volunteers? Yes, Ian. 2.52 grams. What was your mass of penny after? Mass of penny is 0.09 grams. All right? Now, what do you think this whole mass of penny is from? What are we assuming it to be? The mass after is all copper. Are we assuming this is all copper?
Yeah.
Is that right? Yeah. So now, if I need to calculate the amount of zinc, how do I arrive at the amount of zinc in the penny? Subtract what from what? 2.52 minus 0.09. Is that right? 9, 10, 11, 2, 4, 2. Is that right? Grams. So the penny was made of 2.42 grams zinc and 0.09 grams copper. How do I find my percent of copper in the penny? How do I find my percent of copper in the penny? Its percent is always what? It's always part by whole times 100. What will be my part? The mass of copper, which is what amount? What is my mass of copper, guys?
Ms.Geeta, we checked the calculation.
And I calculated wrong? 9, 10, 11, 12. That is correct. This is 3. That is correct. All right. So, I don't know how to subtract. Sorry. Now, what is my percent of copper? Its percent is always part by whole times 100, right? So, what is my part? What do you think is my part? The mass of copper, which is what? What is my mass of copper? 0.09 grams. What is my whole? What is my whole? The entire mass of the penny, right? Times 100. All right? And what is my percent mass? 0.09 divided by 2.52 times 100. And that is 3.57%. Is that right? Now, if you actually go to US Mint website, all right, US Mint is what makes these pennies. Is that right? And they publish this data. They say 2.5% of penny is copper. All right? They say in their website that penny contains 2.5% copper. So, is there a discrepancy between their value and the value that I calculated in the lab? So, there is a percent error. Is that right? So, let's calculate percent error. What is the formula for percent error? Anybody remembers? Actual minus experimental, and it's the absolute value divided by actual times 100. That's my percent error. So we're going to find out how much mistake we made in calculating our mass. All right? So what was the actual value? 2.5 minus, what is my experimental value? 3.57 divided by 2.5 times 100. Now, does it bother me that 2.5 minus 3.57 is a negative number? It's the absolute value. I'm just going to ignore the negative sign. Is that right? So 2.5 minus 3.57 divided by 2.5 times 100, I get it to be 42.8%. So what is my percent error? It's really huge. So I'm getting more copper than the US Mint says has put in my penny. Is that right? Can you guess why is my value high? What could be the possible source of error?
Human error.
You never include human error, Muhammad. What is something that you can control is a source of error? What? The tool could be one. Anything else? The water. If the penny contained water, was not completely dry, would it add to the mass of copper? What else could be a source of error? Was some of it still black? Right? So, if it's black, do you think there's still zinc sticking onto it? Will it add to the mass of copper? That's another source of error. Some people can get less than. Who will get less than 2.5% in their lab? When do you think that will happen? When you break the penny, you file the pennies. Do you remember? Did you lose some of the copper there when you filed it? Did you account for the difference? You really did, right? So the filing could have removed some of the copper. Some of the copper can actually dissolve. I actually have a beaker here. Even though copper is not supposed to dissolve, if you leave it for a long enough time, you see the blue color? Alright? If you leave it for a long enough time, this is lab result, alright?
Wow.
It turns, whenever copper goes into solution, what is the color of the solution? It is blue. So the copper, if it dissolves, you lose some of the copper. Does that make sense? For between 24 to 48, it should not lose. So this is a lab that was here for a long time. Do you understand? Do you understand the lab? Okay. I'm going to stop now. I'm going to stop recording. And we are now going to take the quiz. Wait. Before this. I don't know if you remember. Some of you were absent last class. So we removed the zinc from the penny. How did we remove the zinc? How did we remove the zinc from the penny? So what is that reaction? Zinc plus hydrochloric acid. Zinc plus hydrochloric acid. What happens to the zinc? Like, does it completely disappear? No. What does it become? It becomes zinc chloride. And did you see bubbling? What was that bubbling due to? Hydrogen. All right. So if you write it out in symbol notation, this will be zinc plus hydrochloric acid gives ZnCl2 plus hydrogen, and hydrogen is a gas that bubbles and leaves. Zinc chloride dissolves. Is that right? Zinc becomes zinc chloride, and now it goes into solution that you can pour out. Does that make sense? All right? Yes. We will do it. It's a long way there. You have to know how to write formulas, and then we'll write chemical equations. How did I know it was ZnCl2? I have to teach you that. All right? How do I know it's H2? Why can't I write H? Why do I write H2? All right? I'll teach you all that before we write equations. Do we understand this lab? Are there any questions? Okay. We are going to take the quiz 2 sides.